Let's derive the equations of motion for constant acceleration, also known as the XUVAT equations. First step is to define our terms. Our first term is x, for displacement in meters. For most exam boards including WJEC Maths, this is an s. Next is u, the initial velocity in meters per second when time equals 0. Then v, the final velocity in meters per second at maximum time. We have a, acceleration in meters per second squared. And finally t, time in seconds, the only scalar quantity here. Onto the actual derivation. From definition, acceleration equals change in velocity over change in time. We can rewrite change in velocity as final velocity minus initial velocity. If we rearrange this equation to make v the subject, we get v equals u plus at. This gives us our first equation, equation 1, v equals u plus at. We can also derive equation 1 using a graph. If we plot velocity against time, we can see that the gradient of the line is equal to acceleration. If we label the initial velocity u and the final velocity v, we can see that the gradient is equal to v minus u over t. If we rearrange this equation to make v the subject, we get v equals u plus at, which is our first equation again. Now, if we look at the area under the graph, we can see that this represents displacement, x. This area is a trapezium, so we can use the formula for the area of a trapezium to find x. This gives us our second equation. Now, we can derive the third, fourth, and fifth equations using equations 1 and 2. First we make t the subject of both equations. Then we set the two equations equal to each other. From here, we first bring like terms together and then factorize the left-hand side. Finally, we rearrange to get our third equation. v squared equals u squared plus 2ax. So now we have three equations. One for v in terms of u, a and t. One for x in terms of u, v and t. And one for v squared in terms of u, a and x. Next, rearrange equation 2 to make v the subject. Then we bring all terms to one side. Next, we multiply both sides by t and then rearrange to make x the subject. This gives us our fourth equation, x equals ut plus 1/2 at squared. Finally, we can derive our fifth equation by making u the subject of equation 1 and completing the same substitution from before. We now have all five equations. To summarize, equation 1, v equals u plus at, equation 2, x equals u plus v over 2 times t, equation 3, v squared equals u squared plus 2ax, equation 4, x equals ut plus 1/2 at squared. And equation 5, x equals vt minus 1/2 at squared. But why all five? This is because each equation has a different variable missing. This means that depending on what values you have, you can choose the most appropriate equation to use. Equation 1 has no x, equation 2 has no a, equation 3 has no t, equation 4 has no v, and equation 5 has no u. When using these equations, first list the quantities you know and want to find, then select the equation that has these in it. Thanks for watching, and I hope this helps.